Hello guys, welcome back to the eBPF programming session. I'll be sharing my learning experience in eBPF throughout this session, and if you have gone through my previous sessions, you could have found that I was discussing eBPF's defensive capabilities by utilizing different trace points and network related eBPF functions such as XDP and TC filters. If you have gone through that videos, you could find that. And in today's session is a bit different. I will be discussing more on K-probes and offensive use cases of eBPF. And mainly I will be discussing on how I did develop a keylogger using K-probes. And one more thing, this is going to be the first part of the keylogger development. After the demo, you will find that why I did say the first part of the keylogger. It's a fully functional keylogger. I will show the demo. Let's dive into some theoretical things needs to be addressed, because I never talked about K-probes previously in my videos. I did mention that on one of my earliest videos related to eBPF. And if you ask what a K-probe is, or K-probes are, is a mechanism in Linux kernel that allows you to dynamically break into any kernel routine and collect debugging and performance information non-intrusively. And it's basically used for tracing, debugging, and monitoring kernel functions without modifying the kernel code. You can put any you can break into any kernel functions using K-probes. Basically, you can collect the information. You can just see the information what exactly going on. It's very useful for debugging. I'm not a Linux kernel expert. I'm exploring Linux kernel using eBPF nowadays. And yes, as mentioned, you can insert a K-probe at a specific location in the kernel function, and when the kernel execution reaches that location, the K-probe triggers. So at that time, you can execute. Just imagine you put a K-probe on a specific kernel function using an eBPF program. Then when the K-probe reaches when the Linux kernel function reaches that execution point, it triggers that eBPF program. So you can collect the information of the corresponding K-probe using your eBPF program. And the better part is, after the eBPF program runs, the kernel resumes execution of the original function. So we are not blocking any execution until you do some unexpected things on the eBPF function. So that's how basically it works. And today we are going to explore some of the other new things. And one of the things is this structure, pt underscore registers. Actually, I think regs I can say. And it's a kernel structure that represents CPU register state at a specific point of execution. So it means the values of this register depends upon the functions, which function you are utilizing when you're running a eBPF program. You can make use of this structure in any of the functions in eBPF, because this is provided by default, just like the structures that is related to XDP programming that I introduced when I was showing the demo of XDP. Just like that, this is another common structure that is provided by eBPF. So you can fetch the function arguments. That's the main thing. We can make use of this one. You can check the function arguments at runtime, and it doesn't have any it has all the function parameters inside the structure. The only thing you need to know is you should know how to fetch that, and you should know the function parameters. What are the type of the function parameters? As an example, here I will show how it works in my keylogger one. For my keylogger, I was using one K-probe is called input event. In that okay, I'll show that when I go through the code. And basically it provides a standardized way to access CPU register values across different architectures. and you don't need to worry about on different architecture based parameter representations. It provides some macros that will help you to do that action, and this is very helpful. pt_rgs PARM parameters, and basically you can define the architecture and you can use these macros. So based on the architecture, these macros will fetch the parameters for you. You don't need to worry about which register has which parameter. This will do these macros will do that for us. And okay, now let's go to, and further regarding the keylogger. Actually, I have tested with two different kprobes. One was input handle event and other one was input event. The second one is an exporter function. When I was checking with ChatGPT, it was recommending the second exporter function. But even before that, when I was searching, I got input handle event, and I used that one also. I think I couldn't find any difference between on function wise, but as I said, I'm not a Linux kernel expert, so the second one is as an exporter function, so it is highly recommended because it has more visibility other than the declared file. So ChatGPT was recommending me to use the second one, so I use the second one in my demo, but I will show the other source code. That was the same kind of source code, doesn't have any differences because both of these function signatures are same, but only difference is the second one is an exporter function, and this is defined inside the input. This is input.c under the drivers input folder. So that's all about the theoretical part of this one. I can share the code with you now. So this is a basic eBPF code that capture the keys. So it's nothing but, if you have gone through the other videos, you could have known what exactly this one is. I just created this VM links using BPF tool, and I created this header file included here just to ensure I have all the required structures and other definitions for my kernel. And the error I was facing when I was using this one was it was complaining regarding the architecture definition, so I had to put this one specifically here. And if you have some doubts on that, you just go and better search for this one. I always search for these things because this is really helpful. If you have any doubt what exactly this macro is, where it is defined and how it is defined, those things. So when you search and go and see the actual source code, it will be really easy. So you get more clarification on that. If you go here, this is for 4 point, I think. For the 6th version, maybe you can go to 1.12 here and search for this one. See, it is defined in BPF tracing.h, and this header file, if you go here, you can see the definition of this 1, 2, 3, 4, 5 according to the requirements, parameters. You can access the parameters from the kernel function using this. This actually reads parameters from the registry at the time from the register the time of execution. So if you go here, you can see how it is defined and why. Actually it needs to be, we have to define the architecture for this one. It has, if you it is here. See, if you see here there's you can see the definition somewhere here. You see when you if you see this session, you can see that it asks for it creates an error for the target missing when you are using this one in x86. So that's the reason why I explicitly mention my target. So this will fetch the registry values according to the target defined here. And I don't know how to explain that more on that. I was going through each and every part of that, and I realized for x86 we have to specifically mention the target to make use of these macros. Otherwise it will generate the error that I just shown, the target missing, this one BPF target missing error. So after declaring the target, you can make use of this one. And regarding this function, as I mentioned, this is defined here in input drivers input and input.c file. Here you can see two functions. Where is that? Yeah, the first one is this one, input event. And when you are going to use the PT regs the parameters, the macro, you should be knowing this one, the exact parameter list of this function. Specifically saying you should know the signature of the function. You should know what is the first parameter, second parameter, third, fourth, whatever it is. You should know the order of the parameters and what are the type of the parameters. Then only you can convert that to exact values that is expecting. So here I have 4 parameters. The first one is input type device, that's a structure, and second is the type of the device, and third is the code, actual code of the key, and the value represents whether the key is pressed or released or those kind of information. And the other function, you can see here the input handle event, both has same number of parameters, and I tried with both and both worked well. But after I did both, I checked with ChatGPT, and ChatGPT was recommending me to use this one because this function, if you see here, you can see an export symbol, so it has more visibility outside this than this. That's why ChatGPT told me I had to dig deeper into that area. What's the difference between these two? But when I tested both, I didn't feel any difference on this. And if anyone knows what's the difference between these two, just tell me how exactly it works. What I got from ChatGPT was it's always safe to use the exporter function instead of this one. So that's all about the functions, and as I said, you should be well aware about the parameters of these functions, because we are going to use this and we have to convert these parameters according to that. So the PT regs structure has the parameter values, and I'm taking the parameters and assigning to according to the parameter type. I'm not using the first parameter here, it's input device. I'm not using that here. In fact, that's why I'm not taking it. Actually, I tested it when I was developing this app. I tested it and I seen what exactly inside that. It's a structure, and if you go through vmlinux.x, you can see what exactly the structure is and what are the members of the structure. If you want to see explicitly, you can access those members if you want to take that. And here the env key, and another thing I use here is the key input key code events. Actually, I copied this header file information from the kernel source code to my local file. Actually I did it's a time of testing and I didn't even change that, because all the key definitions are here, and this one, as per the theory or definition, it says it's explicitly setting up for keyboard events. so that's why I use that one there. And you can see all the other keys are defined here, all the key codes. So it was easy for me to keep it locally, or otherwise I think I have to use the user API include Linux, and then input even like the include function will be the other path, not the path on the double quotes. I hope that you know the difference between putting this one in double quotes and in this angle bracket. So I just kept it here because I wanted to check my type of event that is generated from the keyboard or not, and value is always checked with 1 because I wanted to take only if the value or the key is pressed. 1 means is pressed, I think 0, and there are some other, I don't know how to check the exact values. I was printing the values here and I was confirming it, what happens when we press or release the keys. And value 1 was for pressing, key press or key down, I think. So whenever when we press a key, what it is doing is for the testing purpose, what I did was this is just for tracing message that I will show you when I'm running this. I'm just printing that type of the event. And the other thing I have created here is I'm just creating one structure with one member, that is key code, and actual key code. I'm saving the actual key code here. So whatever the user presses, it just takes the key code. Key code means the key. Every key on the keyboard has a corresponding key code that is defined inside this input event codes header file. So I'm taking that information, and then I'm sending that information using a ring buffer to my user space application. I have discussed these ring buffers before in my other videos. If you have some doubts on that, you just refer that. It's just a mechanism that effectively we can send data from the kernel space app to the user space, and from user space to kernel space. Either way you can do. So here I'm just sending information from here to my user space app. So every key that is pressed on this, whenever this app is running, it puts a hook, or it's a kind of breakpoint, or whenever the input event kernel function is getting called. Normally it is getting called whenever user is doing anything with the input devices. So at that point, our kprobe of eBPF function will get executed, and using this structure I'm just accessing the parameters. These are the main parameters I need, and I'm taking the key code into my structure, and I'm sending that to the user space app using a ring buffer. I'm just making a buffer for my ring buffer, and assigning the key codes to my structure, and submitting the ring buffer to the user space. That's all about accessing keys. And why I did say the first part of the keylogger here, I didn't deal anything with related to modifiers. Actually, I learned a lot about the low-level input functions because after I did eBPF keylogger, I realized how it is easy to make an user space user space keylogger, not related to eBPF, but it's pretty easy to make a keylogger in user space because we have more polished events or ASCII codes when we use user space applications. But here I will show you that how it works, then you will get the difference. I haven't checked any specific states of keys like shift, caps lock, or any other modifier keys like control functions. Nothing. I'm just directly taking it and sending to my user space application. And if you come here for the user space application, as as usual, I have created a skeleton file using my eBPF, and I included that here, and I'm using the same input event codes here also because I want to check the keys here. What I'm doing is I'm just sending my key code here and getting corresponding string related to the keys, and these are the keys defined inside the input event codes, and whenever that key code is matching, I'm just getting the corresponding string representation of the keys. That's what this function is doing. And I got these function lists from using ChatGPT. So ChatGPT initially gave me a part of this, then I asked the complete list and it generated the list and the corresponding string representation. So it was easy for me to convert this key code to string value. So what it's doing is basically setting up the memory for our user space app. That's what we do for every function, and I'm just declaring my ring buffer structure here. Then I'm loading my function, my eBPF app. If you have seen my previous videos, I have explained how we can create a skeleton header file and make use of skeleton header file to load it, load and attach easily with the skeleton file. You can do it manually. If you are going to do it manually, you have to call a lot of other functions. You have to keep your eBPF object file with you every time when you want to do this. But if you are using this one, normally the easiest way is just convert your eBPF object to a skeleton header file using eBPF tool, then include that header file inside the user space application, and load it according to using this one, because all these functions are defined inside the skeleton file. So the heavy lifting will be done by the BPF tool while it's creating the header file. So all these other actions are the normal one. I'm just creating space for my creating a new ring buffer. Basically, I'm allotting space, and I'm fetching that information from the skeleton files, maps, and key events. And if you still have doubts, I can show you where these things are defined. It is all these maps and key events are defined inside here. So if you check the maps area, see this is a lot of structure, and we are calling all these things there. And you can see the map. The map is not a pointer, that's why we use dot notation. And normally when it comes to, suppose if I want to access any information from inside this one, this is a pointer to a structure, so we have to use hyphen and angle bracket, open angle bracket, greater than symbol to fetch the information. So that's what I'm doing. I'm just see, I'm using maps dot because map is a structure, is not a pointer. Is a structures object without a pointer. It's a direct copy. But if I want to access anything inside the key events, I have to use other notation, pointer notation. So this is a syntax, and this is a handle event function that is associated with this ring buffer. So whenever some value comes to the ring buffer inside this loop, we are polling the buffer using the allocated ring buffer here. So what happens here is whenever some notification comes to the ring buffer, this function will get called. And what happens to this function is this function has these parameters, and it has actual data and the data size, and the data is the main one, that is the actual structure that is generating the data. So I'm just assigning that here, because, and one more thing is you have to define the same structure here as well. It should match this structure should match your eBPF app, because we have to take this convert the exact value. So both structure should match, and we are taking that value here. Once after converting that, so basic checks. If there is any issue on that, it says incomplete data. And another interesting stuff I noted, that was really a weird scenario. Whenever I was trying to print with the new line, I was getting it printed on the console, but when I was removing the new line, I was not getting any information. It was not showing anything to the console at all. So I checked with ChatGPT. Then ChatGPT suggested fprintf function, and yes, it worked perfectly, because now it is printing really good on a single line according to the keypress. So that's it. This will happen till I press Ctrl C. So whenever I press Ctrl C, and this error will occur and it will break, the application will stop. So that's all about the code. And see, it is initially it was very difficult for me to come to this stage, because I had never used any kprobes. All the only kprobes I used or I was familiar with was the syscall related stuffs, but no other functions. So this was, and the other difficulty I faced was this is if you have noticed here, I couldn't use the macro BPF kprobe, and it was generating error, because the BPF kprobe had to have instead of this one, if I was using that macro, I had to define a name for the macro like this. Then I have to specify the parameters. I tried with the exact, because BPF kprobe macro says you should supply the exact number of parameters that matches your function. So I tried to supply exactly like this. Then it was generating a lot of errors. So I just went back to the normal trace point kind of stuff. I just gave a name to the function, and I removed everything, and I decided to go with this one. Why? Because I have seen a recent project in Rust that is a complete perfect keylogger. They are doing very advanced stuff. They are not only capturing keys, and I think they are sending dynamically to the C2 using DNS. So it was, but the only thing was it developed in using Rust, and I'm not that much familiar with Rust. I know Rust, but I'm not that much comfortable in using Rust in eBPF programs. But what I'm planning for the next version of this one is I'm planning to convert this to Cilium Go, so I may get more control over the user space application, so I can send my keylogs to my C2 using some other not DNS but some other mechanism, maybe over HTTPS. It is plain normal key sending mechanism. So this one I'm not sending any data to anywhere, I'm just printing it here. So that's why I mentioned it's a first part of the keylogger. And here the demo, I'm just going to make my eBPF app, and as I mentioned, I'm going to make my skeleton. So I have generated this skeleton file from this eBPF object, so I don't need this eBPF object anymore. I can use this header file. So I'm going to make the user space application now, and see, here is my user space application, and this is my name of the application. So I'm just clearing it. I'm going to run it. So now it started listening for see, when you are seeing this unknown, why? Because I'm not taking any any mouse related events there. That's why it's showing for every click of the mouse it's showing unknown. So what I'm going to do here is I'm just clearing here. See, you can see I just pressed CLEAR and enter. Why you are seeing everything in capital letters? Because I didn't use any logic to check which modifier is or the current state of the caps lock. So from here, when you see you have to it's your assumption that the caps lock is off, because whenever you press caps lock, actually it shows you have pressed the caps lock, and if you press something again, it is showing the same thing, same set of caps letters, because key codes doesn't differentiate between the normal lowercase or uppercase. It has only one key for both codes. So what we have to do is we have to see now from this key logging mechanism, you have to identify yourself that what kind of key the user has pressed. As an example, if I say when I am saying the left shift and 1 2 3 4, actually I have pressed the special character symbols like exclamation, @ hash and $, but the key code for that one is unfortunately the same. If you want to see what exactly it is, I think here you can see you can say where are the key codes. Let me search for this one, key_a. Okay, see, these are the key codes, like for ASDFG, that combo, the keys 30 31 32, whatever it is, whenever you press a key, the key code is same for lowercase and uppercase, and the differentiation comes from with the other keys, like the combo keys that I just showed you. It's called modifiers. So for the next version of this one, I had to implement the modifiers for this one. So it will be, see, every key it is fetching. The only problem is you don't see the modifiers here. You can see all the keys that is pressed on this Linux machine. So whatever or wherever you are doing any key press, every key press will be coming here. So, and the other difference is that if you want to see, I have trace point here in this one, and you can see the type of this, the type and the code for corresponding code for this one, value for this one. See, it needs, see, the type of this one is showing as 1, and this is something that I'm printing on my eBPF app here. Where was I printing that? Yeah, I think it is here. Yeah, I'm just taking the input type. I already printed this one. I thought I enabled this one. So if I would enable this one, it will have printed like the type of the event and the code corresponding to that and the value corresponding to that. Yeah, you can try that yourself and just analyze the other part of this app. Even if you see Control+C here, you can see I just print left control and C. See, everything is coming here, and for the other thing I need to filter out is the mouse event. I don't want to trace the mouse because why the mouse events are coming as unknown is because on the function here for getting this string representation of the key code. The default value I put as unknown because I'm not checking any mouse related key codes here. That's why if I have explicitly mentioned any mouse related key codes here, I could have done that one, because this key information, like here it has mouse related information. I forgot about what it was. It is somewhere here. If you yeah, it's a button. The BTN, see BTN mouse, BTN left, right and middle button. So if you added that keys here instead of the unknown, you could easily find out that keys too if you want. So that's the first part of my keylogger function. It's still in development because I could do far better than this one. At present, this one is just fetching all the keys without any modifiers. The next version I have to implement some logic that should toggle the caps lock key state and the shift key state. So according to that, it has to print, instead of directly printing everything, every keystrokes, it has to check the modifier state. If it's a shift key, then the user is pressing letters. Then according to that, it has to check whether there's uppercase or lowercase letters. I hope I can do that on my next version of this one. And next version, I'm planning to make it using Cilium Go and sending these keystrokes to my C2 server. So probably I can do that. Yeah, initially reaching this point was the hardest part for me. So definitely the next will be another challenge for me to learn more deeper into eBPF stuffs. And honestly, I learned a hell lot of stuff related to Linux kernel and how the kprops works and the different types of kprops. And this is, if you see the input handle event, this is what I was saying initially. I used both input handle event and input event. Both worked well for me. There was no difference in functions. I did the same code on both sides and everything worked perfectly. But yeah, the other one is an exporter function, so it might be recommended to use this one. There might be a reason for that. I'm not so much familiar with that, why it should be and what exactly the export symbol is doing. The only thing that ChatGPT told me was the export symbol means it is available outside the module. So that might be the reason. Okay, that's all about this offensive eBPF series, the first part of this one, and hopefully I can come up with the next one soon. So till then, it's a bye from Alphas. See you soon.